Hello,
And
everyone.
let's keep going. Hello, everyone.
Hello, YouTube.
This is one more lecture on the review for the final exam. Let's continue. So, triple integrals, we did this spherical last time. That was a short example. This is a good multiple choice problem. Let's do the long one. This is the one with maximum and minimum. And you pay attention on what I say, mostly because I'm sleepy. So if I mess up, you should tell me. Minimum, maximum. Okay, I mean, it's Saturday, so. And saddle points. Do you guys remember that? That required lots of steps. Point. So let's practice. But it was a good topic, though. Usually students actually like it if they remember how to handle these problems. So this is a good both free response and multiple choice question.
Excuse me, Professor. I don't think you're sharing your screen.
Oh, thank you.
I thought I was going mad.
Thank you. See, someone actually cares. Okay. Extra credit on the final. Smash that. Oh, you see, someone reminds me, please like and subscribe my channel. Yes. Yes, Dr. Payam actually mentioned that now when he got his whatever silver plate or golden plate for getting more than 100K subscribers, now he's getting $9,000 per month. No, let's see. No, he's getting $1,000 per month. Yes, that is pretty cool from his YouTube on. I'm like, okay, maybe I should actually invest more time in this. But let's not get distracted. Critical points. When you see the maximum minimum, it starts the same way as in calculus 1. You start with derivatives because we need critical points, CPs. Now it's just partial derivatives, and it used to be hard at the very beginning. But now I think you're professional in this, just like as always with derivatives, it's hard at the beginning, then it gets easy. With respect to x is 3x squared minus 3y. With respect to y, it is minus 3x plus 3y squared. As always, you set both equal to 0 and try to solve. This is a system of two equations with two unknowns, so it should have a unique solution based on the theorem from algebra. And usually you just solve for one and plug into the another one. So for example, from the first equation, let's solve for y. Y is x squared. Plug into the second one. Then I will have minus 3x plus 3x squared equals to 0. And from here, you solve for x. Minus 3x plus 3x to the 4 equals to 0. Divide by 3, factor out x. We'll factor out 3, doesn't matter to be honest. Let's do 3x minus 1 plus x cubed equals to 0, gives you two roots. X is 0 and x is 1, not plus minus 1 because it's cubed. So I have two solutions for x. That gives me two solutions for y. Points. When x equals 0 and when x equals 1, plug back to your y. Y is x squared over here in the box. So it's 0 and 1. That gives me 2 points, 0, 0, 1, 1. Two critical points, they are both in the domain, so we can consider both. And now we do second derivative test. So now calculus 3 starts. This was still kind of calculus 1, just with partial derivatives, but the idea is the same. Now we do second derivative test. Remember we had this d, I'll skip the step, skip some space. D was fxx, fxy, fyx, fyy, determinant of this matrix. Well, either you write it down separately, first find all the derivatives, or just look at them and right away plug it over there. The thing is, well, let's just write down to have good notes, I guess. Second derivatives, fxx. I'm looking at the first expression and differentiating with respect to x, 6x. Fyy, second with respect to y, 6y. And the mixed one, fxy, choose any because they should be equal when functions are smooth, surfaces are smooth. With respect to y is -3, and you can check the other one, yx is also -3. So I have 6x, 6y, -3 cross product gives you 36xy minus 3 times -3 is 9. That is the determinant. Why do you need that? Because the sign of the determinant will determine kind of maximum, minimum, well, at least the saddle point. So step 3, identify or classify. Just to classify. Classify points. Come on, coffee. Why it's not hitting? Not hitting in. I still feel so sleepy. Let's do it. Determinant at 0, 0 is -9. That is negative. Who remember what it means? Anyone wants to say? I should probably check the chat to make sure it's decent.
If it's less than 0,
Saddle point.
doesn't mean it's going to be a saddle point.
Thank you. Good job. So the negative one is the happy one because it's saddle point and you don't do any extra move after that. Saddle point. So the saddle point is your chip, piece of chip, because it is maximum from this point of view. But it is like a saddle, but it's minimum. Oh yeah, I remember. But if you do it 3-dimensional, like so, then it is minimum from that point of view. Anyways, check it in the 3D, it's a better picture than 2D. So saddle point is good. This one is fine. How about 1, 1? Plugging 1, 1. It will be 36 minus 9. Again, I don't care about the point, the number. I care about the sign. Positive. Positive means we don't know. It's either maximum or minimum. So we need to have one extra move after this. Check the fxx sign at that point. So fxxx, no, just x. Fxx at 1, 1 is 6x times 1. That is 6. That is positive. So let's review that. If both are smiling, both are positive, the face is smiling, that indicates minimum. If the first one is positive and then a negative, then it's kind of grumpy face, so that's a maximum. Am I correct or not?
Yes, that's correct.
Nice. Minimum point at 1, 1, like so. So we classified and found. If we ask you to find the very nice answer, then it's extra step at the end, 4. Answer. We have a saddle point at 0, 0, going to the very original function, plugging it in over here. 0 minus 0 plus 0 is 0. So the height in z dimension, that is 3-dimensional function, is 0. Minimum point at 1, 1. Let's go back and plug here. 1 minus 1 plus 1. 2 minus 3 is minus 1, such a coincidence. Minus 1. These ones from the original. Total like in calculus 1 class. What do you think about this? Again, some of these pieces can be easily be done as a fast multiple choice or free response. Then you know the drill. You just need to do the whole thing. Not too bad. Now, let's do line integrals.
Wait, to get the height or the z coordinate, we just plug it into the original equation, correct?
Yeah, yeah. That's
Can I see the original equation? Because I think I wrote it down incorrectly then.
Here it is.
Yeah, wouldn't that just be +1 then? It'd be 1 minus
1
1
plus
plus
1. 1 plus 1 is 2. 2 minus 3 I think it's -1. 1 minus 3 is -2. -2 plus 1 is minus.
Oh, wait, hold on. I did this wrong. Yeah.
Yeah. Okay.
I did 1 minus 1. My bad.
Good job for checking. Move on. More stuff. Now, example number 7 should keep track of the numbers. 8. Example number 8. Oh, our students from other class don't understand why we're jumping from where the other 6 problems came from. So I started my review on Friday, and you guys don't be afraid. When we finish this, I can go back and review what we did on Friday with my other class. Now I'm realizing that. So this was, before that was Friday. And don't be afraid, I won't discriminate. So at the end, I will go back to what we did, which is a good practice anyways. Spherical coordinates one more time. We did partial derivative chain rule. One more time. We did tangent plane and one more tangent plane and parametrization. So not actually too much stuff. Oh, and the joke. The German saying says, everything has an end except for sausage, which has 2. Today I'm sleepy enough to really like this joke. That's I think it's fun. Let's see. Keep going. Find this integral C f dr. I think that will freak people out on the test because we kind of did so many ways of doing these integrals. So which one should we do? Because we learn like directly, we learn Green Theorem. What is going on here? Let's figure this out. Let's finally summarize why we did so many different methods. Y z e to the x z, comma, e to the x z, comma, x y e z z. Really? No, that's x z. X z, e to the x z. Like so. Luckily, we gave you R of t. Again, when we give you R of t, you should feel happy because sometimes we ask you to create by yourself when we give you upper half of the circle, blah, 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 directed positively or negatively oriented. If we give you this parametrization, you should feel happy because that's quite a lot of work being done for you. Nice. So what to do? Let me just. When we give you this integral, that looks like so, f dr. If it's looking easy to solve or do directly, then you just do directly. Do that. If it doesn't look easy, then you check if it's conservative or not. F is conservative, question mark, and we know how to check that. If yes, then find the antiderivative and use fundamental theorem of calculus for line integrals. Plug the end minus the beginning. Because if it's conservative, just the antiderivative exists. So find the potential function, which is antiderivative, and then use fundamental theorem of calculus. If it's not conservative, you cannot do that. It means it doesn't exist. So maybe then do Green Theorem. Green Theorem, which we only learn in 2D, to be honest. So if no, easy to solve, no. Yes, yes, like so. That's kind of like a nice sketch of the idea behind the line integrals. So if 2D did not work, didn't have the Green Theorem, so it's easy to do directly. In 2D, we don't have, let's see. Yeah, fundamental theorem is the best option, to be honest, but yeah, who knows? The thing is, oh, this is the last material. Very nice. Let's do that. Curl, because definitely curl and conservative stuff will be on a test. Remember how we're checking if it's conservative in 2D? And that was kind of simple. It was mixed derivatives should match. In 3D, we just learn a new way. So who remembers how to check if it's conservative in 2D? This step. This depends on the dimension though. So let me write down here.
Do we check if x of fxy is equal to, or sorry, not that one. If it's py equals qx, right?
Py equals qx, the mixed one, exactly, right? Do you guys agree? This is what we did for the last exam 3. Now we find out that what if it has more dimensions, and that's what we have here. It's a 3-dimensional function here. So in more dimensions, we just don't curl of f. You build this I, j, k derivative with respect to x, derivative with respect to y, derivative with respect to z. Your stuff, which is p, q. What was the last variable? P, q, what? R? I think so. Yeah. I forgot. And then this should end up to be what? 0, 0, 0. That is the idea. Because when you do the determinant, you kind of have those little pieces, py minus qx, that is 0, and other guys. That is 0, and other guys, that is 0. And that's why it's the same thing, but in upper dimension. 0, 0, 0. We're still checking the same equation, actually, just with higher dimensions, because we have 3 variables now. We check all the 3 pairs to be equal to each other, so the difference will be 0, 3 times. And that's what we're going to do here. So there's going to be, let me see, maybe I can even tell you. What is the written part of the test for now? Okay, you guys can do that. We reviewed that. Yeah. Okay. Potential function. Definitely potential function is going to be there again. Flux will be there. Okay, fine. Let's do this one. And also, if we do this, and then it's kind of feel comfortable putting it in the exam. 20%, I can change 20% of the exam. And to be honest, I do more sometimes, and kind of, I mean, nobody cares that much. It's not like someone gonna come and check. Unless everyone gets 100, maybe someone will come and check. So kind of fine by me. Fine, I always have a backup plan. If everyone gets 100 and they come and check, and I don't do exam too easies, and then I'll say, well, students were just really amazing this year. I mean, they cannot beat that, right? You cannot argue that. Sometimes it's just amazing. So that's my backup plan. Solution. This integral is not easy to solve. So let's check if it's conservative and then proceed after that. To check if it's conservative, we're using curl for upper dimension because we're working with P, Q, and R this time. This is my F or R. Then my R. And then we're gonna have enough space. No, those are actually derivative. Yeah, your F. Your F. I, J, and K, derivative with respect to X, derivative with respect to Y, derivative with respect to Z. And then find your F. F is Y, Z, E to the n, so on. Basically, just rewrite it really fast. I, Y, Z, E, X, Z, E, X, Z, X, Y, E, X, Z. Okay, cool. And now really fast. You multiply this accordingly to check if you get 0, 0, zeros. Well, really fast, that was kind of funny. Let's do it in vector notation right away, so you don't have to write I. So I, that's a first component. Cross product these two with minus inside. Derivative of this last term with respect to Y will be X, E to the X, Z minus. Derivative of this term with respect to Z will be copy exponential function times by the chain rule times X, this X. Oh, it is 0, so looking optimistic. Next, J will be negative, so I put negative. And then multiply, so it will be this component with respect to X, Y, E, X, Z minus this component with respect to Z. Oh, it's product rule. Seriously? So annoying. Okay, fine. This is product rule. Let's really fast do product rule. This one and this one. U times V. Derivative of U with respect to Z is y copy the second function, kind of blink out for a second, plus yz times e to the x z times x by chain rule. This goes away. How about the other part? Does it go away? Some term is missing. Let me see. J. Oh, this was also a product rule. That's why we have 4 terms. U times V. I see, fine. This is also product rule. With respect to X, the first term will be Y, copy e to the X Z plus, with respect to X, second term, copy XY, e to the X Z times X. Times Z actually, plus. Cancels out, cancels out, cancels out, 0. See, I'm being sleepy and still can do it. So that's not too bad, but this is too complicated for the exam. Who does product rule on a test? That's just kind of weird. I will have to change that to make it better. But
in fact, it's evil. It's really evil.
Right? Like I was just surprised as well. I did not know this before. K, derivative of e to the x z with respect to x, e to the x z times. Well, the last exam actually had integration by parts, if you remember, but I did remove it. It's like, who wants to do people integration by parts? Are you kidding me? Minus. And now this one is not product rule. Z, E, X, Z. Cancel out, cancel out. Nice. It is 0, 0, 0. So it is 0, 0, 0. Conservative, conservative. And that helps you now to practice how to find untitled derivative of the conservative vector field. A, we check its conservative based on the dimension. So the upper dimension, unfortunately, has this annoying upper dimension calculations. Lower dimension, we just reviewed. You will do just this, which is easier. You had it on exam 2, exam 3. Now find potential function. Find the potential function. It's already on the exam. Definitely, we want to check that you remember that again. F is given. We want to find a small f, which gave you capital F after differentiation with respect to x, y, and z. So with respect to x, you have y, z, e, x to the z. Then f will be integral of that. Integral of y, z, e, x, z with respect to what? With respect to x. Integrating that will give you y, e, x, z plus some kind of c, which is not a constant. It can be a function of other variables as well, as you remember. Again, so that was 1. The other one will be integral of e to the x, z, dy with respect to, so that's with respect to y, which is y x e to the x, z plus c2. Finally, the last version of f is integrating this last component, but with respect to z will be, that's just dividing by x, so it will be y e x z plus c3. Some books explaining it a little bit more complicated way that you need to figure out the other things. We usually say write down without repetition. It works. Write down, collect, actually. Collect without the, probably, yeah, repetition. Repetition. F. Let's see, we have y e to the x z, y e to the x z, and y e to the x z. Oh, okay, that was boring. So only one term stayed. This was given because they asked us to find, what was even the question? They asked us to find this integral from 0 to 2. So now instead of figuring out the R, all those derivatives and stuff, we find an entire derivative, gonna plug 2 and gonna plug 0. Very nice. Step 3 is the main one. That's C. Step C is fundamental theorem of calculus. The moment you find an entire derivative, everything changes. because integral dr can be written as integral as a product of the gradient dr, and we found f. So f plug the end minus f plug the start, kind of like top minus the bottom, right minus left, but in 3D it's literally the end and the start, the bigger and the smaller one. But the thing is, we need to find first what the heck is that. F depends on R, and we don't really know R of 2, and we don't really know R of 0. So let's find that first. R of 2, plug it into your R, R of 0, plug into the 0. So calculate carefully. 5, 3, 0, 1, minus 1, and 0. Your F is three-dimensional. It has Y, X, and Z. So we need to have 3 components. Answer will be integral f dr is the antiderivative we just found at 5, 3, 0, that's the ending point, minus f at 1, minus 1, and 0, that's the beginning. Plug into the function we just found. It is going to be 3e 5 times 0 minus 1 e, just a minus e 1 times 0, which is 3 plus 1, which is 4. And you found it. Let me check. What do you think about this? Yeah, the way book explains is a bit too complicated. I also saw it. I was like, that's not how I used to do it. And we just remember collect things as it. Jan is like, you're the math professor. You should be able when you sleep. I don't know, maybe somehow, I don't know. The master student is confused. Any questions? What do you think about this?
Just to double check, you said we're likely to have a 2D example in the test, not a 3D one.
Let me see. No, that's not what I said. I said if you do have 3D, you don't have to do product rule. That was a little bit extra. But answering your question, let me see. I remember there was a Green Theorem there. Definitely. I see 3D and 2D. But I just realized I need to be careful when I will be fixing the exam they gave me, not to have any product rule or integration by parts. That is a little bit too much work. Even I got annoyed right now, it's like, it's not even an exam. So that is good. Yeah, these questions look good. Very doable. The conservative, I already can see, verifies conservative, and it's good. Flux. So who remembers? Yeah, people keep asking, is it mostly new material or old material? Surprisingly to me, it's everything is there. Literally starting from equation of the plane passing through the point, or 3 points, or point and parallel to the plane. So that's what we were reviewing on Friday. We will do more. And then are these relationship parallel or orthogonal or whatever, like these kind of questions. That's what we did literally in the first exam. And maximum, minimum, saddle points, directional derivative. Find the maximum rate of change. Do you remember that means gradient? Reverse the order of integration. That's the one you hate the most, I think. You don't like the reversing the order. It is there. So the position function, find the position function from the velocity. Those are my favorite ones, so they will be there. There's a picture on the exam, which I don't like. So I will change that. I will delete that thing. And Green Theorem at least twice. And of course, either spherical coordinates or cylindrical coordinates are there. Usually it's multiple choice. Surface area, that's what we just learned recently. Flux, that's what we just learned recently. Partial derivative chain rule, we practiced on Friday. I will do more today. The equation of a tangent plane definitely is there. So yeah, that's actually pretty good. Well, it's a lot, to be honest. It's a lot to remember.
I'm assuming it's the same format, correct?
Yeah, exactly the same format as before, just longer. So more problems. So let me ask you this question. Where was it? So how could we solve it directly? Does anyone remember that? What does it mean to solve this line integral directly? What was the formula there? That's, I just realized. Do you even remember? Do you remember? Ta-da-da, it used to be. Let's see. So what we just learned, line integrals, we learned lots of different formulas. First, they were even pretty annoying with some kind of fans. We did this idea, and then we learned this, remember? These guys, that's what I'm talking about. So that's solving directly. If you have ds at the end, then you use these formulas. And now you're using it in upper dimension, if you understand. When we have an upper dimension, we do line integral over the surface, right? So C over C. Before, C was just a function, a curve. C is a curve. That was easy. Well, easy. It was kind of lower dimensional thing. Now, in the last chapter, we learned line integrals over the surface. So C now is a surface. So the square roots just kind of increased in the more square roots because we're approximating the surface with tiny parallelograms, if you remember. And they are done with the cross product, U and V, but still just square root because it's the absolute value. It's the magnitude. So it's kind of the idea is the same. So you need to remember this formula. And there was one more formula that doesn't have any vector field here. It's a small f inside. So that actually gives you some area and stuff. This is approximation and stuff. And then we learned the vector field thing. And the vector field thing had a different formula. Again, the idea is the same. You're walking and you're collecting all the arrows on the way. This is the direct idea here. What if you can just find it directly? Then you need to figure out r prime, rewrite your f with respect to r, and do a dot product. A dot product gives you a number. Like so. Sometimes you end, you remember we were asking you to do parametrization. This is literally the example from exam. I put it in exam, the x squared. I remember this. The x squared example. So let's do that. To compare, how would you do it directly? Directly means we would find r prime, we would plug all of these into here. So r prime actually is not a complicated thing. I was like, why would I just do it directly? Let's find r prime. That would be easy. But the next step, I need to rewrite f in terms of t. So this is x, this is y, and this is z, and I would have to multiply y by z e to the xz, and that's a lot of extra work. Seems like that actually is harder than checking its conservative, finding antiderivative, and then plugging top minus the bottom, because x times z and e to the xz is so much work to do. That is my justification why we did not do this way. It was not that easy to do it directly, but just like I said, maybe write down the formula. Directly is when you remember that the formula is f, plug in your r of t times r prime dr. This is the direct way. So if you believe that is easier, then you do it this way. Like in this example, when we created parametrization, plugged it in, found derivatives, and did a scalar product, or basically a dot product. And then we learned Green Theorem, yes. Let's do this example really fast to review the direct way. Direct way is kind of a dumbed down way. Honestly, in general, people use antiderivatives or Green Theorem. No. So the direct way was taught at the beginning, like explaining the idea behind this, that we multiplying your vector field by the derivative of the parametrization R. That's kind of you're running and collecting things on the way. So let's try to do that directly. Solution, let's find R prime, but then what is your R? R is not given, that is set, you have to figure it by yourself. So this is a parabola. We don't need the whole parabola. We're just looking from this point 1, 1 and this point 2, 4. That was your exam thing. So from 1, 1 to 2, 4. So you can figure out the parameterization. Step 1, create parameterization if it was not created for you. Let's keep x to be a parameter, just call it t. And you see, recently I told you x can be x, you don't have to rename it. So in recent material, we just kept z to be z and so on. That is actually very legal. People do it quite a lot. Y equals t squared. Done. T is from what to what? Well, since t matches with x, probably it's from 1 to 2. So I only need these coordinates. Checking, it should go from this point to this point. So let's do the derivative. This is your r. Remember, the moment you create x and y, your r is x and y, a collection. How would you like this? A collection of your x and y's. So r now is t and t squared. Yay, we created parameterization by ourselves, where t is from 1 to 2. Very interesting. Sagar mentioned to me that in the homework you have right now, the last chapter, they have this notation. For example, x, comma, y are from, what was it, like -1 and say 10. So comma means both. People were just lazy to write down 2 lines of equations. X is from -1 to 10 and y is from -1 to 10. But this means that they're both are from -1 to 10. That is from your homework. Just new notation, I wanted to bring it up. Sometimes people do x, y, z, m, and all of them are from -1 to 10. That's a notation. Yeah. I extended your homework to you tonight, by the way. The last one, 13.7. Too many people asked. But make sure you know the priority exam is your priority because it's more heavy. Let's find r prime. Step 2, r prime is 1 and 2t. Nice, that was fast. Step 3, rewrite your f. F was in terms of x and y, as you can see. We need it in terms of r, which is in terms of t. So we need to figure out x is my t, sine of y becomes sine of t squared. That was easy. Y is t squared. And that's why directly it makes sense doing it directly in this case, because it's just easy. Finding antiderivatives here, maybe it's also good, but maybe it's not even conserved. And now you build the integral. Integral f dr is, oh, did I ever mention the work done? You remember that the work done on the force, that is an integral. That's one of the applications of the integral over the field f. Say f is some kind of magnetic field, which is moving the particle. So we're wondering how much it was moving the particle. Maybe it was too far from the particle, so there was no difference, but maybe it was actually on top of it, moving it to the left and right. So the particle is moving along the parabola. That's the idea. Now it's going to be integral of the dot product, which is a scalar product, sine t squared, comma, t squared times 1 and 2t dt. And t is from 1 and 2 on c. C is from 1 to 2. Before I move on, what do you think about this stuff? Vector fields and contour plots. Well, that's the thing. There is right now a plot there, and I don't like it. So I will delete it. I think giving plots in the exam too stressful. People will be like squeezing their eyes, trying to see something. Depending where you sit, maybe it's dark. I don't like it. You know. So I will delete all the plots, no contour plots and stuff. But right now it is there, asking which direction some kind of stuff is going, positive or negative and stuff, potential stuff. So, did I do correctly or I messed up? Anyone agree, disagree before I move on? Well, I can check. Since it's over here. Yay, it looks good. Since this is a dot product, you just multiply corresponding components. No need to do any vector product. And you have a function as the answer, and at the end, a number as the answer. The number tells you how much the work was done by the field. If it's huge and positive, the field was helping the particle to move along from 1 to 2. If it's huge and negative, it was pushing it away when the particle was moving from 1 to 2. If it's small, the number is small, and then it was not very touching the particle, and the particle was moving, barely feeling the field. That's the idea. So we're integrating t sine t squared plus t squared times 2t dt from 1 to 2. And let's use substitution here, which is not too bad, but I'm seriously not in the mood to do substitution. So I'll just copy the answer. It's U substitution, as you can see. And it will be 1/2 cosine 1 minus cosine 4 plus 15. One half cosine 1 plus cosine or minus cosine 4 plus 15, which is positive. I just need to know the sign. It's, well, I need to know the number, if it's big or not, and the sign of that number. Positive means, which means your field was helping you, helping that particle to move on the parabola from this point to this point. And the field was like shooting some kind of arrows, up and down. So the particle was checking, collecting all those arrows on the way, just like the Sonic in the game, collecting the rings. And apparently, since the number is positive, the field was actually helping the particle to move faster. Yeah, let's refill the coffee. Guy kind of is correct. Okay, 2 minutes intermission. I like to say the pause for a second. There's my recording button. Don't forget to share. Am I still sharing? Yes. Okay, good. Green Theorem. Since we mentioned Green Theorem, let's do that. Green Theorem, 13.4 chapter. Green's Theorem. That is number 1 from your review, which was kindly provided solution from Kaylee. So integral C 10 xy. I really need to zoom in. It's crazy. 10xy dx plus 10x squared dy, like so, where C is a line segment, well, consists of the line segment, line. Okay, probably that's actually important. Line segment from 3 to 0 to 3, 0, and the top half of the circle, and the top half of the circle. Okay, Kelly, your solution better be correct because I did not check before. So let's find out solution. So Green Theorem, actually people's favorite topic because you guys doing pretty well on that. It's something about Q and X and P and R and a difference there, right? And maybe sketch picture first to see what's going on. Here it is, upper circle, x squared plus y squared equals 9. So this is 3, like so. And so it's moving from -3 and 0 to 3 and 0 first. Then it's go up and then it comes back. Totally like you walking on campus, right? University Drive, half circle, go back, I guess. Green Theorem, who remembers that? So we have this function given, line segment, P and Q are these guys. P, anyway, when you see this awkward notation with dx and dy, it gives you immediately a hint you're supposed to use Green Theorem. Or sometimes we say, hey, use Green Theorem, and then you don't have kind of the choice. So P is, someone write in the chat, what was the formula for the Green Theorem? And Q is 10x squared, like so. Let me check.
Can't you do px plus, or sorry, qx minus py and then times that by the area of your given surface?
Times the area. I like it. Yeah, often we did that because it's kind of the integral. You do the official formula is like so. It's the integral, right? And then when you find this difference, sometimes you just see that the area is easy, so you don't have to do anything else. So I will just write down this for now. Dx, I mean dx, let's just do dr, and it's c in terms of r. You're supposed to kind of switch everything to the parametrization. And then if you know the area, like in this case, kind of, it's pi r squared over 2, then you can multiply by the area. So qx minus py times the area, if it's easy to find. Or, and we had it on a test a couple of times too. So let's find at least the derivatives first. Step 1, we figure out what we have, what we're going to do. Step 2, p with respect to y is 10x. Q with respect to x is 20x. So the difference will be qx minus py equals 20x minus 10x, which is 10x. Very nice. So what else? What should we do after this?
Can you go back to the question, the original?
Sure. Let me see the chat. Someone got roasted in the chat and I missed it. I did make everything in my announcement. Someone even asked where this review will be held, but it's literally an announcement saying this is the Zoom link. You guys are so bad in reading emails. It's just so wrong. But it's fine. I understand. Do we have a final? Okay, Guy, you failed. That's it. That was the worst question. Okay, any more bad questions? So what's the next step? Who knows what to do after this? So we found 10x. Now what?
Going to set up the integral.
But you just wanted to do, you just told me we should do
Well,
times the
yeah,
area.
yeah, but you told me I was wrong.
No, I did not say. I said this is one of the, this way says or. So I'm kind of curious. So how would you proceed now? Anyone? What do you think?
I think I do area because it's just a half circle.
So is it going to be 10x times pi r squared over 2 and r is 3 then?
If that's what you say, Professor.
No, what do you think? Sound looks good to me, but then first of all, it's not a number. It's supposed to be a number. Second of all, what happened with x? So like, what do you think?
Do we have to integrate x?
We still have to integrate. So,
Don't we do like dx, dy?
right, the x dy. And should we switch to the parametric equations or not? That is also a question.
No.
So, okay, if no, let's do that. Then integral dx, dy, 10x, and then what, times the area? So I'm trying to figure out what you guys want to do with that. So say area, well, for now, we don't know what it is. That's going to be x squared over 2, so it's 5x squared. X is from what to what? Minus 3 and 3. Minus 3 and 3, right? So it's going to be from minus 3 and 3. That is 0. 9 minus 9 is 0. Does this look good to you? What do you think? Wake up. Let's do official. Kind of. So let's do the official way as well. Official way is you actually switch to the parametrization. In this case, it's r cosine theta. R is 3. Y is 3 sine theta. theta is from not 0 to 2 pi, we have to stop at pi. R is fixed, it's 3. Then we will have 10x inside of the integral, 10 times 3 cosine theta dr d theta. R is from 0 to 3, theta is from 0 to pi. Integrating that, integral of cosine is sine, so it's going to be 30 here, 30 sine theta. I still have one integral to go. We'll actually from 0 to pi times integral with respect to r is just r from 0 to 3, so times 3. And
Wait,
then sine,
Professor,
yeah.
shouldn't it be r d theta?
No, I will
Oh.
explain in a second why. Oh, actually, yeah, you're right. Yeah, sorry. No, yeah.
R.
R, yeah, good catch. R, then R is my lost 3. So it's also one more 3 over here. That's part of the formula. That is formula. R d theta. Now I have 3 times 3 times 30. That's some kind of number, whatever, 27, 0. And then sine of pi is 0. Sine of 0 is 0. So that's times 0 gives you 0. So this way worked and this way worked. This way we're still multiplying by pi r squared, which is 3 squared over 2. But doesn't matter because it still gives you 0 because it's a closed path. Right? Closed path. Look at this. It's walking in circles like so. So it also matches the theory that we know about it. Good job, Zach. Good job, Ian. So the area is 0. It's not the area is 0. It's this line, it's the integral that gives you 0. The question says, use the Green Theorem to evaluate the line integral to the given positively oriented curve. Consists of the line segment and the top half of the circle. Line integral gave you 0. Because it's closed. We're working in circles, basically.
Professor,
Mhm.
what's up with all your like Green Theorem questions ending up being 0?
No.
Because on the exam it was 0, now it's 0 again.
Let's say just 2 examples from all of them. On the exam, final exam, I already see it there, and it has different types of multiple answers. 5 pi, 7 pi, whatever pi. There's no
How we know
0.
all the answers. Good question, Jacob.
There's no 0 there. So
We're going for the
And-
team. Let's go.
none of the above also is the option. So that was the Green Theorem. And then keep working on other examples because they don't give you 0. And since now you're concerned about this, then do the example 2 and so on. This is number 2. Do the example 1. This was example 1, the example 2 and 3 on the review, which I posted. And then Kelly gave you nice written solutions. So this was very good for the test. You should do that because it will be there. Now, curl and divergence, we already did one problem. We already did one problem. So let's maybe move. Curl and divergence in the review, I will show you which one I'm talking about. I'm talking about, if you go, oh, that's not your class. If you go to announcements, what is the, let's see. Okay, now it's nice. Which ones are you looking at? I'm looking at these ones. That's what I wanted to show. I was sure people don't know what I'm talking about. Practice test files. So this second announcement, second from the last. Here are the review practice ones. Here are the paper from the website. Here's the exam, which has keys. And here is the PDF. Starts with Kelly notes and then ends with Sagar notes. Sagar did the recent material. Kelly did the Green Theorem and curl, which is also recent material. Green Theorem, and so we did number 1 right now. Then curl is here, stop. And then this stuff. This stuff is all coming from here. Where is the exit button? It's all coming from this website, which is exactly very good because honestly, when I need to create different versions, it's too much work. So I like copying problems from here, which you saw in my Gradescope. In Gradescope, I give you the link and say this was number 5. So definitely work on number 1, 2, and 3 from this review. This curl thing has too much extra stuff, to be honest. We just need to know how to find the curl, how to find the divergent. Like these identities, that is extra. You don't need that. We're not gonna ask you to calculate some weird numbers. That is operator multiplied by 9RR. Who cares about that? This is also pretty extra. Yeah. So we just needed to know how to calculate things, which we already did a little bit. One is a cross product, if you remember. And the other one is just collection, is a sum of derivatives. So on a test, we will ask you to find the flux. The flux will be an important thing. So if you see a flux in the term somewhere, then you need to review that. That goes to the next chapter, I think. Let's see. Parametrization. Yeah, flux was at the very end. Parametrization, definitely review that. And the most important, we're definitely going to ask you surface integrals and the flux. And the flux already has curl and divergence in that. So we don't need to have extra stuff asking about this. Well, actually, let me check. Verify that. Conservative. Change the order of integration. Yeah, I'm right about this. So I might ask you if I want to put some kind of easy question, multiple choice, maybe I should just ask you, hey, calculate curl or calculate divergence. But nothing weird like those questions. Oh, if it's scalar, A, B, C, D, D, like, oh, who cares about this? Or these ones also A, B, C, D, that's way too extra. Find divergence, maybe like this nice kind of multiple choice question. I don't know, it's not there yet, but I might put it there if I want something simple. But definitely let's do more of your last chapter, which you guys stuck with, but I extended it due today, which is this surface integrals and flux. Because that is going to be there. I mean, it's already there. For example, let me find this. And you have solutions for these. Surface integrals, parametrization. I will try to give you parametrization, but you still should review that. It's possible at least once I have to ask you to parameterize yourself. Okay, this one is good. 13.1, number 1. 13.7, number 1. Doesn't look like that. That's weird. Let's see. Parameterize. Dot product. That goes to the back of the whole class. Cosine and sine. That's interesting, Sagar. I don't think your solution match the numbers. 13.7, number 1. In your solutions, it does not look like that. It looks like a very different problem to me. Let me see. Am I not understanding something? Okay, I'll show you what I mean. So I'm trying to do this problem, right? Surface integral f is 4xy, 4yj, and 4zk. Your solutions are here. I'm scrolling down to the 13.7. That's the last topic. And it looks like this. 13.7. That doesn't look like the problem I want to do. Right? Is the girl here?
That is one. I just parameterized the sphere.
Oh, you skipped the step.
Wait, what step?
So if this is the same problem or not? Let's see.
Yeah, that's the same problem.
I see. I see.
Isn't the
square-
answer correct?
Squared, I don't know. I did not check the answer. So square root of 2 cosine sine. Let me check.
Yeah, the radius was 2, so it's just square root of 2.
Oh, I see. You immediately parameterized. Okay, then it's the same thing. Yeah.
I mean, it was a sphere, so. Hey, wait, what step did I miss?
No, you get it. Good job.
Okay.
I'm just slow. So that is good. Thank you for explaining. I was happy with this. Let's do this one. This is very typical stuff. Very good for the test. Find the flux. Be happy with that. A very nice typical equation for the spherical. We give you sphere. You know how to work with spheres. So you're good with this. Do it. We give you a surface integral. That gives you a hint. It's 13.7 right away. And then you see the word flux. That is 13.7 right away. So these two terms only show up. Well, flux show up definitely at the very end. Solution. So the flux had something to do with that integral with the cross product. And we have two formulas, if you remember. Either we do the formula with the cross product, U and V, and the marginal of it, right? Or without, R, U, R, V. So which one is this one? That's what I put it in my practice exam, if you remember. Yes, let's see. So which one do you think we should do? Don't forget, you should do the practice exam. Someone asked, do you when it is? I don't care. Just do it before the final. I don't plan to put any deadlines anymore. You figure it. But practice exam will help you to practice. That's the whole point. So there are two formulas. Let me show you the pretty version of two formulas. Here they are. Which one should we use here?
Sorry, the first one.
The first one. How do you know?
Because that's what the formula was.
It's a surface integral, but then the other one is surface integral of f. So the main change is we either looking small f, that's a function in 3D, capital F, that's the flux in 3D. Which one do you see here? Oh, flux, I'm sorry. Capital F is a vector field in 3D. So that's the big difference. This gives you literally a surface. It will be like inches squared, or whatever surface, with F floating function in the air. F may be like a curtain, or a roof of the building, or a roof of the car. It's kind of different shape of the stuff. While this F is a vector field. Vector field, so all those tiny arrows we're collecting while we're walking through F on S. And that's why the formulas are different. For the surface area, we have these approximations of rectangles, parallelograms. Parallelograms appear to be area of the parallelograms, have some connection with the magnitude of the cross product, RU and R times RV. That was one of the property of the cross product, which we learned in a very fast exam. While a vector field doesn't need any absolute values, magnitudes. Vector field needs to have a number at the end to show you, was this vector field helpful or against you or nothing? That's why it's just N. So repeating the question, which one should we use for this example? Let me see the chat. Maybe people are yelling.
Shouldn't it be the second one, corrected? It's a vector field, capital F.
Capital F, I would see it this way, yeah. It says surface integral is not necessary, means the first formula. You need to figure out if we're talking about small f or capital F. Vector field is more complicated. Well, not necessarily with calculations wise, but the idea is more complicated here. So we're going to do the second formula. We don't need to do the marginal here. Does that make sense? So that's kind of for you to make sure you understand the difference. That's why I keep pushing this idea so much. Formula number 2, we need Double integral f, rewrite everything in terms of r, which is not given, by the way, so that's a problem. Find the cross product and don't touch it. So don't find the size of that factor. No magnitude needed. Over D, that's what we need. Formula number 2. Parametrization, it says it's a sphere. Yay, we know how to do the sphere. Spheres are X, Y, Z. You see in the solution, Sagar immediately wrote it down nicely, so you don't have to. He skipped steps because it's just fast this way. But if you need your brain to get adjusted, any kind of panicking, you do R, let's row, square root of 2, cosine theta sine phi, square root of 2, sine theta sine phi, right? Yes. Square root of 2, the only one missing is cosine phi, like so. Square root of 2 came from here. Radius is square root of 2. This is your R. Your R now, and that's why it's nice to skip this first step and just write it down in the row right away, or else it's too much writing. Square root of 2 cosine theta sine phi. Square root of 2 sine theta sine phi. And finally, square root of 2 cosine phi. And then you figure out what your phi and theta are moving from and to, which is theta and phi. It says it's a sphere. I don't see any restrictions on the sphere. That's good. Phi can be only from 0 to pi, from north pole to south pole, theta from 0 to 2 pi. Nice. So this is my R, and we can start doing the steps. Step 1, find R with respect to U, R with respect to V. We did it many times, but let's do it again. And again, that's because we did it so many times, I feel very comfortable putting this on a test.
Professor, can you scroll up a little bit?
Sure.
Thank you.
I am slow. I'm so mean in the morning.
I mean, you're not wrong.
Like Saturday morning, so good reason to be mean. Okay, and it's also not U, it is theta and phi in this case, because U and V is a general notation, and then you choose what U and V are. I will keep going. If you're fine with that, let me find a derivative with respect to theta. It's going to be minus square root of 2 sine theta sine phi. And again, you could kind of start writing down the cross product right away, right? It's too much writing kind of, but it's fine. Theta square root of 2 cosine phi sine theta. And there's no theta at the answer, it's 0. With respect to phi, see phi as the variable. Square root of 2 cosine theta cosine phi, square root of 2 sine theta cosine phi, and finally minus square root of 2 sine phi. I'm taking partial derivatives carefully. I would just write down the cross product right away, because now I have to figure out the cross product. The cross product is that thing. Step 2, R theta cross product R phi is I jk, and I cannot even write down jk because it will take lots of space, minus square root of 2, and that's why I would just do it right away, like so. Sine phi, skip, square root of 2 cosine theta sine phi, skip, 0, jk. Square root of 2 cosine theta cosine phi, square root of 2 sine theta cosine phi, minus square root of 2 sine phi, close, nice. And you hope that they will cancel out somehow, maybe, that'll be nice. Because square plus square gives you 1, or maybe this looks nice with negative, maybe they just cancel out. Let's see, this cross product gives you a vector as the answer. The vector is going to be I multiplied by these two. Let's see. Okay, 0 is good. Square root of 2 times square root of 2 gives you 2 minus 2 cosine theta. Sine times sine is squared. Very nice. Minus 0. Closed. The side ones and this and this will give you minus square root of 2 minus square root of 2 is 2 sine theta And then sine phi, sine phi gives you sine square phi. Okay. And finally, the last one. Oh, and this one should be negative. Remember that. The j is always the negative one. Negative. It's sad guy, j. And then k is a cross product of these. And this one, I think, is going to be 0. Right? Because it looks the same. Minus 2. No, it's not. Because it's minus. I think it adds up. Minus 2. And let me check. Yeah, it adds up. It's going to be 4 of square root of 2 cosine phi. How did it get to cosine phi? Because you could factor out cosine phi, and then sine squared plus cosine squared gives you 1. I think so. I think he's right. Looks good to me. So that will be your cross product. And now it's not the end. Actually, not even close. Step number 3. We need to figure out this f. F is given. I will go back in a second. F is given. Here it is. But we need to plug x, y, and z, which are now different. X is my x square root of 2 cosine and sine, y, and z. Sure, let's do that. Oh no, actually the last term is wrong. I just realized that. Cross that, sketch that, scratch that, minus 2 sine. Okay, now I see you guys complain. Cigar phi definitely looks like theta. Now I see why people complain about that. Phi, cosine phi, yes. Minus 2 sine cosine. Okay, good. I looked at the wrong line. Now we need also f. F. And you know what? I will not be writing it down separately. Let's just write down the integral right away. From 0 to 2 pi, from 0 to pi. And now you have f cross product times, no, dot product of f times this cross product, which is found. We remember that. So we need f times r, theta and phi, like so. It's not, it's a dot product that gives you a number. Let's change your f right away here. It will save for space. F will be 4 square root of 2 cosine theta sine phi. 4 square root of 2 sine theta sine phi. 4 square root of 2 cosine phi times the one I just found, minus 2 cosine theta sine squared phi, matches with Sagar's solution, minus 2 sine theta sine squared phi, matches. In the end, this one I just copied. And now you multiply d theta. Oh, theta actually goes at the end, as you can see, d phi d theta. Theta is from 0 to 2 pi, so I know it goes to the end. You multiply these component by component and add the results. And luckily, some of them actually add up or cancel out. So it will be minus 8 square root of 2 sine cube phi minus 8 square root of 2 sine phi cosine squared phi d theta from 0 to 2 pi, from 0 to pi. Amazing work. Amazing work. Not mine, Sagar's work. It's really good. And now you integrate that. Integral of sine cube will be, that's actually is not an obvious way to integrate. If you remember, sine cube, that comes from the exam 1 on the calculus 2 class, sine squared times sine phi, like so. You convert sine squared into 1 minus cosine squared, choose cosine to be u, sine will be du, and that kind of stuff. Doesn't matter. Let's pretend we're either very smart or we used Wolframov. So that's integration. Integration happening here magically. 32 pi square root of 2. Good. That was flux. Flux represents how much stuff is coming in and how much stuff is coming out. So now we know that actually direction matters, that the vector field cannot just go through. It goes in and out, like a heart pumping the blood in and out. How much is coming in, how much is coming out, and so on. Or for example, if you like biology, leaves have membranes, and it actually matters how much sugar comes in and how much sugar goes out through the leaves. And that is also done with the flux. It's called flux of the sugar dispersion in the plants. I'm very impressed. I remember this right now. Yeah. Not scary at all. This would be just a blind guess. No, that's not too bad. Flux is there, and you just follow the steps, and I will make it a bit easier, calculation-wise. Let me see. Flux is already there as a free response. To be honest, it's not a surprise. It's a long problem, so putting as a multiple choice is just not fair. We need to see your work, and if you messed up in the work, that's fine. But if you know how to do it, that's more points. So if you've messed up some calculations, I don't care. I'll take like 2-3 points out of 14, maybe 2 points out of 14. But if you notice how to do this, that's already impressive. Steps, partial, you choose the formula, partial derivatives, cross product, dot product. In the integral, finish integration. I'm pretty sure there's like thousands of places to mess up here. So that will be hard to grade, but I see you doing fine. You got almost maximum. So that's a written problem for you over here. Find the flux of the vector field. Yeah.
Professor Max asked a question in the chat.
Thank you.
How do we know whether to do theta or phi first in the cross product?
Oh yeah, doesn't matter. Cross product, the answer will be the same. So just be consistent with calculations. It's fine. Yeah, I understand that. You can switch these. This question actually showed up in class. When you work with matrices, then just switching the order is not good. But when you work with the determinants, you can do that. Determinants the answer will be the same. So you're fine. We just do it alphabetically in order. So this is properties of determinants. Yeah. Good question. Thank you for pointing it out. So this is a problem from a test. Again, I'm just kind of revealing. It's going to be the last problem on the free response. So you can prepare this problem, freak out of it, but you open a test, just go to the very end and just do it. Just do it. And here the parametrization took time because we had to like write it down. But what if I give you parametrization? Then the whole process over here can be skipped. This process took a while to write down. What if I give you parametrization and it's damn short? Then you just need to know how to move on. Done. So that's what I see in the text right now. Cost 14 points of your final exam. If you can learn this problem, you already got 14% of your final exam. How cool is that? That's very optimistic, right? So I kind of like this problem, to be honest, from the point of view that if you learn it, it gives you lots of points. We did potential function already and fundamental theorem of calculus. That is also going to be there, which is good. Verify that it's conservative. You guys know how to do that. And this and that. Okay, and then surface integral. Let's do one more surface integral and go back to the previous material, like spherical coordinates and changing the order of operation. Yeah, I mean exactly this same type of problem, like was easier. I would say this was a little bit too much work. This problem, just learn these problems. 13.7, let me tell you. 13.7, number one was good, just too much calculations. What if I give you parametrization? Are there any examples? Oh, of course not. Surface integral. Find the flux 1 and 2. So review 1 and 2. That's actually good enough. I would say the examples in class were better than this. So number 1 and number 2. Review this for the test. And if I give you parametrization, that's even faster then. That's good. Let's do one without F. 14% is objectively not a good grade. Now it means you already gained 40% of the game, right? Imagine you just did one problem and you jump to the next level of the game right away. How cool is that?
Wait, 40 or 14?
14.
Oh, I got really scared that surface integrals were going to be nearly half the test.
No, half of the test will be knowing a Russian language. I'm thinking to give you exam in Russian.
If you make an extra credit question about Russian, I will learn the entire Russian language.
That's such a fun way to procrastinate instead of learning just like surface integrals. You definitely will be learning Russian because it's fun to procrastinate. So funny. Let's see. Example number 3. Let's see if it's actually decent or not. Example number 3. Cigar Solutions will help you out. Oh, it looks very short. No, it's not. Let's see. Oh, it looks not too bad. Example 4 is better. Okay, let's do number 4. Number 4. So what is the difference? Let's see. The difference is the two formulas. Go to number 4. Evaluate FDS, where S is the positively oriented part of the plane in the first octant. So which formula to use here? FDS. And why it is shorter? Let me do this. It still is a surface integral. And it's again, let's see, plane. Now it's a plane in the in the first octant. So let's see here. We're going to have what should we do here? Number 4. Derivatives. The formula. It's kind of the same thing, to be honest. X, y equals kind of not very interesting. X plus y less than 1 in the first octant. And that's not a very good example. That will be too hard for you to do it on the test, so I don't want to review. Kind of lost interest in 5 seconds. Let me see number 3. Number 3 is, yeah, let's do number 3. This one I already see it will be like a problem to explain, and you will be more confused than actually reviewing. Number 3. This is the good one. Is this a flux? No. So which formula should we use? The first formula with the magnitude. Kind of like good news and bad news because it's extra step and I don't know. The bad news here, the parametrization is not given, so we'll have to do it ourselves. But at least we know the formula. This is not vector field. Vector field, and also it doesn't mention flux. So this is literally a surface integral. They asks to find a surface integral, which represents the volume below and above two surfaces from z equals 0 to z equals 4. So let's do this one. Formula number 1 is the same thing, kind of, but you have now magnitude RU and RV, which is this beautiful formula in the red box. F have to be rewritten just like last time, but now it's small f. In terms of R, and the tail of the integral is now a magnitude du dv. F rewrite dot product du dv. So let's do that. Cylinder, that gives you a hint that we probably should use cylindrical coordinates. Do you remember cylindrical coordinates? Yes, solution. X is, it's kind of normal polar coordinates first. Remember polar coordinates are cosine phi, cosine theta, and r sine theta. What is my r? R is 3. So it's going to be 3 cosine theta and 3 sine theta. That is my cylindrical ones. But the third coordinate shows up. That makes a circle going up and down forever. That is just z. So z just goes up and down. So z stays as z. And that's why it depends on two variables. Theta is a circulation going in circles, and then z is the height going up and down. So r is 3 cosine theta, 3 sine theta, and z. That is cylindrical, if you want to know, cylindrical coordinates. And you are good at this. What is my z going from to? Z has a restriction not to go from minus infinity to plus infinity, which is good. It will be like infinite cylinder. It is from 0 to 4. You see, I don't even need a picture here. I just know how to do it. Sounds so bad. But I remember that cylinder into D is a circle. It's like you leave the cup on a table too long and you lift it. It has a circle on the table now and your mom is complaining. So I just remember that. And theta, since it's a full circle, it's from 0 to 2 pi. So that's kind of also makes sense. The full circle is on a table now. And we need to find r with respect to u, that's with respect to theta, r with respect to v, v is z. Each derivative, maybe to save time, start writing down the cross product right away. That would be smart, right? So like, instead of doing this, maybe let's write down r with respect to theta, cross product r with respect to z right away. And then we find the magnitude of that. So I know it's going to be ijk, right? And we're going to spread it out. Derivative of theta with this derivative with respect to theta is minus 3 sine theta, 3 cosine theta, and 0. Derivative with respect to z, 0, 0, 1, I, j, k, right? So that's kind of saves me lots of writing, to be honest, and I'm fine with this on the free response. If you just know what you're doing, then why should you keep writing so much? I is 3 cosine theta minus crossing minus minus. So that's comma here. 3 sine theta, comma, and then 0, if I'm correct. Tell me if I'm not correct. So let me see. Oh, it matches with Sagar's right notation. So I think we're doing good. The extra step here is step 1, parametrization. Step 2, finding derivatives and cross product. I merged it into one step. Step 3, the extra step, is to find a size of this cross product vector. That is the marginal. And that is because the formula requires this extra step. So from cross product, we're now getting into a number because marginal is a number. A square root of 9 cosine squared theta plus 9 sine squared theta plus 0 squared. That is square root of 9, which 3? That is the size of this cross product vector. Step 4, writing the integral, but you first need to figure out f. What you can do it right inside of the integral. Integral d theta dz. F should be rewritten. Here's my f. It's over here. This is my small f. We need to rewrite it in terms of r. So I'm going back to the parametrization, x and y and z like so. So 4x squared, x squared will be 3 squared cosine theta. I forgot immediately. 4x squared y plus z squared. 4x squared y plus z squared. I would kick out the 4 outside because it's kind of annoying to have it there. And then x squared is 3 cosine theta squared times y, 3 sine theta plus z squared. Z is z. This is multiplied by 3 in blue, which is marginal. D theta, d phi. If I put theta inside this time, which doesn't matter, they're all numbers, it's from 0 to 2 pi. And phi is your z, d, z. Z is from z in. Z is from 0 to 4. That was my f. This was f in terms of x, y, and z. And this is f in terms of theta and z. Like so. And then you integrate. This integration is also requiring you substitution, but actually it's at least in front of you right away. You choose cosine to be u, du will be minus sine, and then you integrate super fast. 5, 1, 2, pi, done. Check this out. So that is a surface, literally surface integral, no flux, no vector field. That is the volume. What do you think about this?
As a typical calculus student, I'm more worried about messing up the integral or the algebra and not the actual setup.
Yeah. No, I told you, if you mess up algebra, it takes to take 1, 2 points. That's fine.
Okay. All right. Okay. Thank you.
Your mom's equation. People are crying. That is sad, but understandable. Crying is a big part of the final exam week.
Yeah, I echo Maddie's sentiment. It's surprising that I've only cried 2 times this week.
Oh. They know what Russians do. We have a superstition.
They don't cry.
Yeah, I wanted to say something, but I won't. We have little books where all the grades are collected. So you're required to bring this book called a checkbook. So you bring this book to the final exam week, and then you give it to professor, and professor will write with the signature your grade. And then at the end of the 4 years, you submit this book to the college, and they have all the records. They still have records in their own records, but somehow we're required to have this book with us. I don't know. It's a very old tradition from Soviet Union. And then, so we have a superstition that the night before the final exam, at midnight, of course, you need to open the window or whatever the window, take your checkbook, and then not throwing it away. Instead of crying, we like stick into your hand to the window and then shake it really hard, your book with grades in it, and say, please give me a good luck for tomorrow's test. Please give me a good luck for tomorrow's test. And people say it works. I don't know.
Out of curiosity, was it a little red book?
No. In my case, it was blue. I don't know. It was a blue book.
Did any of your friends have a red one?
No, I think the standard was the blue book. And then also we believe that Tatiana is the goddess that helps students. So we also ask Tatiana for help. So for 5 seconds break. Четная книжка. Yeah, so Tatiana definitely helps. So this is how it looks like. 5 seconds break. Yeah, exactly. The blue one, told you.
There's a red one.
No, there's a red one. Oh,
There's
something.
red book. Let's go.
I want that book.
I never
want
seen
that
red
book.
one. But it looks like this. So mine, that's like the list of final exams or projects. So mine was also filled in. It was like, mine was real analysis, differential equation, complex analysis, differential equation, 1 more, but theory with proofs. Complex analysis, 1 more, but theory with proofs. Discrete math, computer science, and physics and physical education. So you have to run a circle. Like it was all here, and you have to bring it. If you don't bring it, you'll not get a grade. So it will be like incomplete. You have to bring it next time. And then they give you the stamp and stuff.
What happens if your book gets burned down in a burning house?
It happened before. They have to figure out the new one. Luckily, they have all the records, so it's fine.
Professor, out of curiosity, is it the same in like America in like PE, physical education? You have like a uniform you have to wear?
No, our PE was so laid back, but it's in my university though.
Austin, I didn't have a uniform I had to wear.
No.
Oh, see, we had uniforms we had to wear. We had to have like, you had to wear certain things, at least in like grade school, like middle school and elementary school, you had to wear like a certain outfit.
I never did that.
Yeah, well, see, I was wondering if like the professor wore like tracksuits or stuff, but
tracksuits? We trying to say something?
It's another joke. I'm trying to lighten the mood because this review is really hard.
She isn't in a gang.
Okay, that was a good break. Adidas jumpsuit. In my case, it was very hard because because, let's see. Well, there's oh no, that's my university. And then let me charge for a second. That's also good. That was my university, very old-fashioned kind of building. It used to be probably some part of it actually used for the what's the name of those fancy old-fashioned dancing balls? Yeah, balls. We even have like famous poets there having celebrations and stuff. Anyway, but now it's the university. Looks like that. That's my university. My problem was that we had to relocate this math department inside of this university. I have pictures in front of the doors. My problem was that for the PE, you had to like take a train or a tram or a bus and go from this location to the, yeah. Let's see, this one is here. Yes, exactly between these two. You have to take a bus and go from downtown to here on, because the stadium is apparently on the beach. It's over here. And then you still after this have real analysis class. So you have to like run around, do push-ups and stuff, and then you go back. And you have to change in the way. So that was we don't choose the schedule as I told you. So we did not have a choice. That was hard part.
Professor, did they ever make you run back to the main school for your?
Too far. No, that's too far. But I used to go 2 hours earlier because there was no choice. My home is super far as well. My home is like over here. So I would come here 2 hours early and he would know that I was the only student who comes so early, and I would do some homework in my DCQs and stuff, waiting for the class to start. The class will start and then I will take the bus home after this. Anyway, so that was the hard part, to be honest. It's relocation, not the class itself. Anyway, let's keep going. So I did this example, number three. Remember that. Let's go back to the topics of switching the coordinates kind of stuff, which was here. So let me close this. Switching the coordinates. If you go to my reviews, ASU, MAT267, they all are here. Well, of course, not is MAT267. If you go here, then switching the coordinates with in both of these exams. Let's go to second one. The second one, I think, had all of them, right? Let's check. And you guys did not like it, I remember. So polar coordinates are here. Oh, double integrals. Oh, okay, then it's third exam even more important. But you remember that they say change the order to finish the integral. And I do have video on that, so that is also very good. Maybe that's why you just watch the video then, since I have a video on that. Because to switch the order, you need to create a graph. Oh, we did this already, so that's good. Directional derivatives. Okay. Directional derivatives actually also something we should review. It's already noon, I should probably hurry up. Close this. Go back to files. Go back to here. See, you have all the keys. Practice exams. Here they are. Student solutions from Carrie and Cigar. My solutions for the exam 2 merged. This is the one when I actually, who wrote a smiley face? By the way, I can actually probably find it.
That was me.
Of course,
I wrote it a while ago. I don't know why it's showing up now.
No, I noticed. I just don't want to say it. Okay, this one doesn't open because it's too heavy. I wonder if it's opens in general, but let me open it first. Let me download it. Just a second, sorry for the delay. That's all Jacob's fault, which is playing. Oh, it did load after all. I'm actually impressed by that.
Wait,
interesting.
Why are you blaming me this time? What did I do this time?
As always, just why not? So
Jacob, it's always your fault.
Video solutions, here they
Sound like my
are.
parents.
Everything here, right? So definitely we did review partial derivatives, but we can do one more at the end. Chain rule stuff, that one, yeah. All the partial derivatives. Tangent planes. You need to know that the formulas for these. Tangent plane, we reviewed that one, but we reviewed that one several times. So you definitely need this. And then I actually can just post a video from the Friday review. Oh, I did already. Oh, I did such a good job. Yesterday I posted video from the Friday review. I see your little hearts. And then let's see. There's no, someone asked me yesterday, will be differentials in linear approximation? No, you can skip that. But this will be there. The partial derivatives, that's what I reviewed on Friday. So I already posted the video, definitely check it out there. But I think I have a very good video in YouTube on this anyways. Oh yeah, I do. So that would be even better to just check it video by video. Gradient was just collection of derivatives. Maximum, minimum, we just did it right now. The thing is, remember there was a problem asking for this. Yeah, exactly. Let's do this problem. How do you know? It will not tell you the word gradient. So you have to understand that it is gradient. Scrolling. Where am I saying? Yeah. No, it's not the one I need to scroll. This. Do you understand? This problem is asking for gradient at the point. That's why I highlighted it. The direction in which the maximum rate of change is occurring. I remember you guys reviewed it for the second exam, and most of you actually pretty good at this. But you should know what it means. That means the gradient is the one that tells you on every little step, on every little iteration. If you're in computer science and data science, you know that. You code every small iteration, and that means gradient will point you to the maximum change. That's why it's called gradient descent and the gradient ascent. So if you want to know how to come down from the mountain, the fastest way, you just jump off from the cliff. No, but in general, at every little step, the gradient shows you where is this most steepest descent. And the next step again, and the next step again. So if you have lots of mountains, you drop the ball, like you wonder where it's gonna actually fall. The ball will follow the maximum descent. But it's first, you need to create gradient. Creating the gradient means solution. Collecting the partial derivatives, gradient. Partial derivative with respect to x. Remember that was your biggest concern, to find partial derivatives, not anymore. So gradient.
No, what do you mean? I'm so worried about partial derivative. You should definitely put it on the test because it's going to be a really hard question.
It is there. Yeah.
You put what is 2 plus 2?
That'd be so funny. It's like half a point extra credit.
No. Half the, like, if you get it wrong, you lose half credit on the whole exam.
Still, I think rational
Professor,
language
are
is more
we,
interesting. Huh?
100% gonna see like one of those like hard surface integral problems you just did.
Surface integral is there. Yeah, it's already there because it's a new topic. Surface integral and flux are both there. So two different formulas. Yeah. And then it goes back to Green Theorem, and then it goes back to the old material. It's 100%. X cosine x, y. I should put what is my middle name question for the extra credit. Who remembers what is my middle name?
We can't pronounce it.
No, you can't. What is my middle name? Who knows?
Your middle name is your middle name.
No. Goat.
There is no middle name or something.
Right. Max, because remember, Max, we don't have middle names in Russian culture, so I don't have a middle name. That's right. So you plug the point they ask you. The gradient descent or maximum rate of change is this kind of the surface in 3D, whatever the surface is. They give you the point, which is 1, 0. It's a two-dimensional object, so it could be 3. And then find the gradient. Gradient is a collection of all derivatives, so rates of change. And it points at the fastest way to go down is this. And that is the maximum rate of change, changing. So you're gonna plug. I'm just gonna plug 1 and 0 into this vector, and it gives you the direction. It will point, go there. And the ball, when you threw balls on top of this three-dimensional object, will follow that direction. This is 0, and this is 1, I think. Yep, So that is a good question for the multiple choice, to be honest. You just need to recognize what to do. If it's three-dimensional, you just have third variable. Why there's dinosaurs in the chat and the aliens? People are getting crazy.
Do we have linear approximations in this? I don't know if you mentioned it earlier. I wasn't here for the first part of this.
because I'm laughing, you guess. I mean, yes, there will be no linear approximation, no differentials. Yeah, let's keep scrolling. Let's see, gradient, see, 3-dimensional, no, that's not 3-dimensional still. Directional derivatives, this is 3-dimensional. So, but of course, it's not like I'm gonna give you arctangent to differentiate. And times u, okay, what is times u? We did directional derivative. What is the difference between that and directional derivative? I think directional derivative is in a test. Let me check. The maximum rate of change is there. You need to know directional derivative is there as well. Let's review it. Directional derivative gradient. So maximum rate of change means gradient, which is the gradient that. Directional derivative is one extra step. It's only one example and it's horrible. Fine. If a given function is given, function is given. Where is it? I lost it. Gradient tangent line to the level curves here. Find the directional derivative of the very horrible function with arctangent at the given point in the direction of the vector v. Fine, let's just make up different function, not arctangent. But the idea is you create the gradient and multiply by u. But what is u? U is the direction they gave you divided by its magnitude because you want to have a unit u. Let me see. Yeah. That was an exam too, if you remember. This is the formula. So let's do that. Let me just make a function a bit easier. That this question asks a directional derivative with the given direction, like so. Directional derivatives, let me write down. Directional derivatives were right after the topic of the gradient because they have a connected formula. It was capital D. What is the function and what is the direction? That is the notation. And then the formula was, find all of these. It's D is the gradient and U is your direction. Find the gradient, dot multiply by the direction, but be careful, we only need unit direction. We don't need to have or include the size of u. So to get rid of the size, you should unitize it or make it unit. And usually we don't give you unit u. That's why we call it v, not to confuse you. Let's change the stupid function in something easier, like x plus y squared plus z, right? That's just easy. Let's change that. What else too annoying? So step one is, let's find gradient. To find the gradient, you find each derivatives. I would write it down right away, which is derivative with respect to x, 1, to y, 1. Nice, that was good. Now, when you found this, don't forget, we need to find at the point, because the idea of the directional derivative is there's kind of some kind of surface floating around. The point is given -8 minus 8 minus 8. The function is given. We found derivatives of that function, and then the direction says there. That is the idea. So that's a directional derivative. So let's find this at -8 minus 8 minus 8. That gives you 1 minus 16. 1. So it's 16 about 18, like so. 2, we need to check if u is given. No, u is not given. V is given. So let's unitize it. Yes.
I'm a little bit slow. Can you just like leave that top bit up there? Thank you.
Let me drink that. Let me read the chat. Watching other YouTube videos. I'm also a bit slow, says Guy. Organic chemistry discussion. You guys are just distracted. If
No,
you
no,
were
no,
the
but-
OCT, no, I'm joking. it's
No, but in all seriousness, Max does sound exactly like the organic chemistry tutor.
fine. Funny. If you were the OCT, then you wouldn't be in this review asking questions. What is the OCT?
It's a YouTuber who like literally knows everything. He has
Ah.
review videos
Organic
for like
chemistry tutor.
Oh, I
Yeah.
see, I see. That's very good. That's very good.
The chat's full of nonsense.
Russian flag. From Turkey.
Yeah.
Exactly. Yeah, sounds like that. Again, emojis, dinosaurs. Are you Googling her middle name? I don't have one. Haha. And a snake. That was the weirdest one. Why there's a snake there? Okay, fine. So we shouldn't have a pizza party. Yes, we should. I was not invited. That's upsetting. But his plan got canceled. Poor Noah. Okay, good. Let's keep going. We found we found partial derivatives at the point u is not given. So we need to figure out its v and divide by the size of v. V is given. It's going to be minus 10,7,7 divided by the square root of 100 plus 49 plus 49. That will be the vector minus 10 over a square root of 96, 196. Okay, I did it. 196. What is square root of 196? Who knows? People are still distracted.
14,
What?
14,
13,
14.
14. You guys distracted me with your chat. 14, thank you. 4 times 4 is 16. Yeah, that's good. Over 14. And now we finish the product, which is this, the gradient times u, which is unit. Be careful with that, or u less, or else you will lose points. So it's going to be 1 times minus 10 over 14, which I should have simplified, but whatever. Minus 16 times 7 over 14, which I should have simplified, but whatever. And plus 1 times 7 over 14. Find this in the multiple choice. This is not a free response question, so find it there in the list.
Professor,
Mhm.
isn't it supposed to be root 198 instead of 196?
Root 198.
So
Yeah, you're right,
minus
you're right.
49
Mhm.
is-
Yeah. The root of 198. You're right. What is root of 198?
It's root 198. It's 14 and a bunch of decimals.
Thank you. Root of 198, root of 198, and root of 198. That messed up everything, but whatever. 198. Find it in the multiple choice and you are good to go. Done. Happy face, but tired. So this is good, right? You guys are good at that. That's a good small multiple choice question, I think. Now, let's not get distracted and keep going. With keep going, I'll go back in a second. Don't worry. Tangent plane, we did it on Friday. Laws, see this things. Tangent plane through gradient or normal vector. Temperature of the gas, maximum rate of change. That is gradient. I will not put 2 questions about gradient. That's too much. Critical points, that will be part of the problem for maximum, minimum, and stuff. Optimization problems, no.
What about
Just-
T and B? Do we have to worry about that?
Oh, good question. Actually, someone did ask me it yesterday. Let me see. Do you want me to put TNB there?
Maybe not.
See, it depends on what we're removing. If we're removing like a surface integral problem, of course. But if we're removing maximum rate of change, not really.
Surface integral is there. That is not a condition. Yeah. No, there's no T and B there. But I will decide to put it or not. And I don't think you guys like it. So like, T is a derivative divided by its size. So to be honest, that is not too bad. N is normal divided by its size. B was the hell. So definitely no B. But to be honest, you guys don't like it so much.
Professor, you already said no T and B, so we're gonna
Yeah.
hold you to that.
Let's not just put it there. I think people will not do well anyways. And it's
Wait,
too
are
much
we
material.
gonna on the test? Is it gonna be like only spherical or only cylindrical, or is it
No,
gonna be
I
both?
already see different cases. I need to choose which one to put. So it's usually either cylindrical or spherical.
So it's
Because
never gonna be both.
no, too much. One of these will be there.
So can you
But-
tell us which one?
No,
What if I? Never mind. I was gonna
no,
bribe you, but
If I got hit by a car, will you tell me which one's gonna be on the test?
no. So we also need to learn triple integrals. It's just spherical or cylindrical again. Yeah. So I'll be choosing one of these two. I think it's too much, but it's typical like exam 3, basically. You had spherical or cylindrical or both, remember? No Cartesian because it's too boring. So this one is definitely on the test again. And parametrization. Find the following correct expression for the, oh, really? Okay, there are more formulas with it. Do you guys remember arc lengths at all?
What's arc length?
Arc lengths. There was a formula for arc lengths. I also don't remember that.
Arc length is similar to the magnitude equation.
Yeah,
If
exactly.
if you don't say we know it, she might not put it on there. Don't say
But
we
it's
know
an
it.
but it's an easy though.
No,
You
it's
just
easy,
need to know.
Jacob. Jacob,
Yeah.
if she puts that for a free response, I will be so happy.
To be honest, arc length is a good thing if you remember the formula, of course. So do you remember?
What's the formula?
Yeah, who remembers the formula?
Kaylee?
Okay, should not have.
Yes.
What's the
Oh,
formula?
look at this integrated integral. We should do that one first, later. Okay. Arc lengths formula, but it was,
Is
what
this like the
chapter was
one
it?
plus the derivative squared or something?
It
Wasn't that
was,
for chapter 11?
which name of that? Of the
The,
chapter?
I don't know the name of the chapter. I'm just guessing.
Let's try some kind of shape. It might show up. It's parametrization formula. Remember we did like that? And then we had this. Yeah, exactly. Oh, that's a good example, actually. Copy. Look at that. I just found a good example. So, let's see. Find the length of the helix given by. Look at that. I told you, it's a good example, actually. You just need to remember what to do. It was a square root of, and you either create parametrization by yourself or you don't. So the thing is, square root comes from the magnitude, remember? So it is actually a magnitude from -5 to 8, no, integral from -5 to 8, magnitude of the r prime, not r, the derivative of r, dr, dc, kind of. So we're already going about t, so dt. That is the idea here. If r is given, you just differentiate it. So r prime is 5 times 4 is 20 minus sine of 40. Don't forget chain rule, please. Chain rule is important. You guys should remember chain rule already. 20 cosine 40 and 5. That is your r prime vector. Then you find the size of that. So literally, when you have a curve, in this case, it's a helix, you approximate it just like in calculus 1 with tiny segments, right? Remember that? So those are square root of, that's length. So it's a square root magnitude of that vector, the size of that vector you just create. between the points. And we either give you the points or t. Remember in the exam you had it actually, I do remember. I think that's a good question. Yeah, it's a good question. So, or points. If we don't give you t, then you have to find yourself. From the points, it was anyway. If you need to find t, it's actually tricky because if I plug -5, it's going to be 5 cosine 20, like so, and I give you this as a point. So from here, you will have to find t as arc cosine. So that also was the question like that on your homework. I remember this. But not too bad. That's all. That's pretty good. Arc lengths. And then I just saw that Professor, can I skip the file? The president just called me and I have to go on a super secret mission to save the world. Sure, you're just gonna get F. You just need to like your priorities go save the world, but you get F in the class. That makes sense to me. Such a funny question.
No one, if Guy said that, we would believe it.
Right? But Guy would not say it because he
Yeah,
knows.
Guy definitely is a super secret spy.
I totally think so too. But we should not say it. That we might get in trouble, right?
But that's part of his cover.
But see,
I
but
was
see,
thinking
no,
that he's
no.
a spy.
No,
I'm
no,
ve-
no.
I'm
See,
very
if we
sure
think
about
if we give out the secret that he's a spy, all of our lives are in danger. You know, if the professor suddenly goes missing, I won't be surprised.
Heck,
All I'm saying is
What the heck?
Guy is a secret agent. But better watch out.
what the heck?
Yeah, Professor, don't answer your door if you see Guy.
Guy comes
Like,
to all our doors.
Guy's
today.
gonna come knocking at your door. Don't answer it.
You
It's like
better
his door-
watch out. You
It'd be funny if Professor's doors just got a knock on it right now.
Dun, dun, dun. So reversing the order. Dun, dun, dun. How about that? Do you remember how to reverse the order? Let's do one small equation on that. But I actually have video, so maybe you can just watch the video. But reversing the order is there, to be honest, unless I change it. I'm not sure how good you guys are at this. But it's kind of an easy problem unless you mess up, which is literally the definition of the calculus class. It's an easy one unless you mess up. Calculus 1, I would say. Calculus 3 is not easy. But do you remember how to switch the order? I have YouTube video on this, so I guess I'll just post this video. But it comes from the picture. Okay, let me read the chat. Would you like me to do this problem or no? Let's see. Robert says yes. Fine. Let's do it quick. So let's see. Reversing the order. Again, for now it's there. Unless I take it out and change with something else. We'll see. Come on. Go. Of course, I'm not even surprised. Integral from 0 to 1 and 4y to the 4. Integral from 0 to 1 and 4y to the 4 of e to the x squared, dx, dy. This is reversing the order. Reverse the order. People in another class like, who is Guy? What the heck is Guy? Yes, so funny. Yeah. Let's do that. The step to reverse the order, you cannot reverse the order just easily if you have functions as the limits of integration. That's the rule. So the thing is, you cannot integrate this with respect to x. There's no formula for that. Integration by partial substitution will not work. Numerical integration will work. Simpson's rule probably will work, but you cannot do it exactly. That is impossible integral, and that's why this example is smart. To integrate this easily, you have to reverse the order and integrate this with respect to y first. When y shows up, your substitution will work. Step 1, the picture is the key. Let's draw this. to draw these things, you actually need to review that x is this function. Let's make a list. X is 4y and x is 4. Those are functions. X equals 4 is easy to draw. Looks like that. X equals 4 on the x-axis. Y, x equals 4y. If you don't know how to draw this, well, actually just need 2 points, but it's y equals x over 4. Technically speaking, it's just something like that. That's it. I know how to draw y equals x, and then 1 over 4, it just makes it upper or lower. But if you want, you can have 2 points. That's too bad. X equals 4y. If you plug x and y, 0 gives you 0. 4 gives you 1. 0, 0, 4, 1. Boom, done. So like so. Now, to reverse the limit of integration, you go back to the calculus 1, to be honest. Or calculus 2. No, area between graphs was calculus 1. So you have right now, you are scanning in this order. It tells you the order from this line to this line. So apparently we're scanning from left to right, but then that's my x. While y is going from a number 0 to number 1. So y is going from 0 to height 1. Like so. So we want to change that. Now we want to have, now we want to have double integral dy to be inside. Don't touch e to the 4x. That's not fine. E to the x squared. Y should be in terms of functions, and then x should be in terms of numbers. X will be easy because x is from 0 to 4. So let's put it right away. Numbers always go outside. Y now should be from a function to function. Y should go from lowest one to highest one, because that's how it was doing before, from the bottom to the top. What is y function here? Y equals 0. What is y function here? X over 4. So it's going to be from 0 to x over 4. And kind of you're done. That's all. What do you think about reversing the order? Imagine this problem. And we ask you to choose it from the list or to finish integration. Now to finish integration, you integrate first with respect to y. So it's just going to be integral 0 to 4 is waiting. That's going to be y e to the x squared, plug the top minus the bottom. So it's going to be x over 4 e to the x squared dx. I skipped the step, if you understand. And now this is a perfect u substitution. Choose this to be u is x squared, du is 2x dx. And you move on. And you can finish. What do you think about that?
I don't know how we got oh, sorry. I made a mistake. I thought
No
never
problem.
mind.
Not a problem at all. No problema. Как дела? What is happening? Where will we be able to see our final score? Sagar, seriously? You first take final exam, then you wait for a week. I grade fast, you know me. So on Monday, I have my exam with biology class. I might try to finish it, but maybe not. I first finished biology class grading. I'm actually thinking to finish your class first because you guys are more concerned about this, and biologists, they feel like they don't care, to be honest. But for them, it's the last math class they have to take. So for them, it's like also the end of their math career. I don't know. So I'll be grading math 251 on Monday, and then you guys, and on Tuesday before our class. And we have final exam super late, so I won't be grading on Tuesday. On Wednesday, depends when I wake up, I will start grading your exam, and I probably will finish on Thursday. If nothing goes wrong and I don't get sick or something, I should be able done by Thursday, both exams. I'm pretty fast, you know that. So when we'll be able to see Oh, we'll make them. Who is doing sure? Sure. Yes. Nothing important in the chat. Anything I supposed to know? Lol 101. Yeah, Sagar is like, seriously, when can I see my 100? so, so true. So true. And also I will have to, it will take lots of time. It will take us lots of time not grading, but actually collecting all this extra credit I promised. That's the big mistake I did, is to promise so much extra credit, because now I have to figure it out, and that's what takes time. Who is number 20, top 20 in the forum? That will take time to figure out. Maybe I should give someone like Mehdi, like, here's a list, can you give me the final list? Yeah, that would be nice actually, if someone did for me.
I'll do
Who
it.
is top 10, 20 in the list, right?
I'll do it for you right now.
I need to figure out that. We still have a couple of days left. Whose meme is the best one? That's also extra credit.
Right now it's me. Right now it's me. I'm
Who is that?
holding on.
Austin?
Yeah, I'm holding on by a couple. I really
Guys,
thought
just
mine
for
was
hearing
gonna
that, we
win.
should get rid of that. Make Austin's the
No,
worst. On
that
everyone
is
unlike
incorrect.
Austin's right now.
No,
Then I
guys, come on. Don't do me that dirty.
Then I promised lots of homeworks extra credit. Which ones did I promise? I have to go dig out that information. Anyway, totally. Now it will take so much time. It totally was a mistake. But you
I
guys
think
asked.
you said all of 13.7 was extra credit.
I remember that because it was recent. But it was also some like long time ago, right?
And I think you
You
said
think
for
11
13.6, like if you do,
Yes,
there's
11.6.
like 2 problems you're dropping.
So could you make 11.8 all extra credit?
11.8 was not assigned, so you're fine.
But
What else we should do? Let me see for a second. Let me see the exam one more time to make sure we reviewed everything. But let's see, reverse the order. We did in class jumping from velocity to acceleration, from acceleration to velocity. You guys review by yourself spherical and cylindrical coordinates. We have videos on that. So I think it should be fine. Somewhere at the very end. Review the video from Friday because tangent planes will be there, and tangent planes can be done through normal vector, tangent vector, and stuff. So that's also is confusing. I did several examples on that. We just did this. Yeah. Green Theorem is there. Surface area is there. Partial derivatives. Of course, conservative fields and anti-derivatives, which are potential functions. Definitely flux, definitely surface integral. This one I was curious. I need to change this one. But find the region bounded by. We had this in exam 3, so check that, region bounded by. Critical points, directional derivatives, maximum rate of change, that is gradient. Equation of the plane passes through lots of different cases. 3 points. Normal vector and a point tangent vector, partial derivatives, cross product gives you normal vector. So, or just points are given, create vectors, find the normal vector. So that will be there. I'm pretty sure you will not do well at this question with what is parallel, orthogonal, intersecting, or overlapping. So probably change that to something else. Arc lengths, I think I should keep it. It's a good problem. What else is good to do? Let's see. Let's see the total review and choose from there. Maximum minimum values, we did this. Oh, that's previous exam actually. Let's go to the final review. So you guys have solutions on these. Again, thank you to Sagar and Kelly who wrote this down. You have this, lots of Green Theorem, review that. Ooh, that looks very good. Curl and divergence, review that. And then surface integrals and flux. And then we're going to the old stuff. Dot product. I mean, nobody will ask you just to find dot product. That's too simple. Cross product is already covered inside of the curl and divergence. So it's not going to be a separate question either. But this is going to be there. The equation of the line, equation of the plane through 3 points, through a point and perpendicular, through between two planes, and between two planes is not going to be there. So definitely review these. We have them solved already in previous reviews, which I'm showing you again. It's all the files are here. Which my lord, someday. All the files in my announcement, it says literally exam files. Here they are, files. So you practice the test. Remember, you need to do that for the grade. And all of these are here. All the solutions are given. So that is definitely very good. And then let's keep going, see what else is here. Particle moves with the precision, find the acceleration. I mean, usually we do the opposite, the integration. The integration is initial value problem. We did it on Friday. Directional derivatives, we just did. Gradient vectoring, we just did. Minimum, maximum, we did that. Know all three cases. That is going to be there. Oops. Double integrals over the general region. To flip the order of integration, we just did that. Polar is already part of some equations, so it's not a separate question, but triple integrals are there. Review all of them, cylindrical and spherical. Review these. As always, I'm gonna put something straightforward, so nothing too complicated. Line integral showed up. Remember how to do these. I just reviewed several cases, direct integration or conservative field, and then anti-derivatives, and then plug the star and minus the star. Green theorem, fundamental theorem of calculus shows up. That's it. That's what we covered. And then green theorem, curl and divergence, parametric surfaces, and then we go to the very beginning. You see how we learn all of this: dot product, cross product, equation of the line planes, motion in space, directional derivatives and the gradient. We learned then. Minimum, maximum, we learned after that. Double integrals became triple integrals really fast. Triple integrals became Cartesian, cylindrical, and spherical. Then line integral showed up. Line integral is the typical integral, but not over the from x to y. It's over the line, and that's why it's so complicated. How to integrate something over something that is already curling like a line. Fundamental theorem of calculus for line integrals is the same idea, and minus the start. And then green theorem. Then surfaces. How to parametrize the surface. Find the integral over the surface, between surfaces. Integral over the vector field. What is vector field? Vector field can be over the line or over the surface. That's called surface integrals. Pretty cool. You guys, we covered so much. It's definitely high respect to all of you surviving this class, because this is pretty cool. Look at that. With that, Jacob is getting crazy. We definitely, look how much we covered. 4 months of hardcore material. It's so intense. There's definitely high respect to all of you surviving, regardless of the result of the final exam. Just surviving this class is really high respect. Because many students actually dropped, for you to know.
How many?
Many. So what do you think about all of this? I think that's good enough. 32.5 hours.
No. Wait, Professor, what is like your fail rate of like students that fail Calc 3 in your experience?
This is the second time I'm teaching it, so I don't have big data. But in my
okay.
previous class, we did really well. My classes are doing much better than other classes. Unless unless it's like A section or B section. That one has horrible 50% or more rate failing.
Oh my
rate.
Professor, wait. Thank you for everything you have done for us.
Yeah.
From Calc 1
Yeah,
The
You're welcome.
practice
Calc 2
exams are so amazing.
Calc.
You have no idea.
I have been blessed to have you for Calc 1 and Calc 2 and Calc 3
Yeah, you know.
And Calc 4 and Calc 5.
and Calc 4.
Thank you.
Well, I mean, literally all the other professors are terrible. I mean,
No, not all.
really,
Hey, yo, it's
you're
getting
probably the
recorded,
best professor I've ever had.
I have
Can you
popcorn
Can
for
you
this
stop the
situation.
recording so then we can go off?
Yeah.